All right, today our guide into a completely hidden world is something you've probably never even thought about, a technical inspection form for an industrial ammonia engine room. Now, I know, that sounds super dry, but trust me, this checklist is like a secret map to the incredible, unseen machinery that keeps our modern lives running. So, let's dive in. Seriously, just think about that for a second. All the ice cream, all the frozen veggies, all the meat in every single grocery store for miles and miles. It all depends on these enormous cold storage warehouses, and they have to run 24/7. But what keeps them running? What's the thing that stands between a perfectly frozen food supply and a total catastrophic meltdown?
You got it. This humble piece of paper, just filled with checkboxes and a bunch of technical jargon, is actually going to be our expert guide. It's going to pull back the curtain on this incredible world of machinery and the just meticulous attention to detail it takes to run it all safely. It's a story of prevention, of brilliant engineering, and of the unseen guardians that are all around us.
So here's the game plan for our tour. We're going to start with the big picture. Then we'll zoom right in on the key pieces of the system, the powerhouse, the vessels that hold everything, and the parts that do the actual chilling. We'll even check out the support crew. And then, at the end, we'll see why a simple document like this is one of the most powerful safety tools ever invented. Okay, so to wrap our heads around this really complex system, we're going to need a simple analogy. So for a second, just forget all the pipes and machines, and let's think about something we all know, the human body. This right here is the key to understanding everything. The whole ammonia refrigeration system works just like a giant circulatory system. You've got a heart that pumps, you've got arteries and veins that carry the flow, and you've got the lifeblood, in this case, ammonia, that does all the heavy lifting. Just keep that image in your head as we go, and I promise it'll all click into place.
So naturally, let's kick things off with the heart of the operation. Every circulatory system needs a powerful pump, and in this industrial world, that pump is the compressor.
The compressor's one big job is to take low-pressure ammonia gas and just squeeze it, turning it into a high-pressure, high-temperature gas. This is the absolute first, most critical step. I mean, without the compressor, there's no pressure, there's no flow, and there's definitely no cooling. It is, quite literally, the heartbeat of the entire facility. And here we go, we're looking at our source material for the first time. This is a real piece of that checklist. You can see how a technician just methodically goes down this list, checking things like the integrity of a fan shroud or the security of motor mounts. Now, these might seem like really minor details, but they are incredibly important. And this is the whole point, understanding why they check these things. A cracked fan guard isn't just a small problem. At thousands of RPMs, that thing could disintegrate and turn into dangerous shrapnel. A little bit of corrosion could be the very first sign of a dangerous leak. And a worn-out belt? Well, that's like the heart skipping a beat. If that belt fails, the whole system grinds to a halt, and you could lose tons and tons of food. Okay, so the heart is pumping. All that high-pressure ammonia has to go somewhere, right? Well, it travels through the system's arteries and veins, a whole network of pipes, and these massive containers that they call pressure vessels. Now, these are not just simple tanks. They are highly engineered containers built specifically to hold ammonia under absolutely immense pressure. They're kind of like receivers and reservoirs managing the flow of that refrigerant all through its cycle. And again, if we look at our checklist, you can see just how meticulous this process is. Technicians have to visually inspect everything for corrosion, they check the insulation, they even have to make sure the little nameplate on the vessel is still readable. And I know, that last one sounds almost silly, but it is absolutely vital. See, that nameplate has critical info on it, like the MAWP, which stands for Maximum Allowable Working Pressure. In some of these systems, that can be 400 psi. Now, to put that in perspective for you, your car tire is probably sitting at around 35 psi. This is over 10 times that pressure. Now you can see why checking for even the tiniest weak spot is so important. This is just a brilliant example of that whole philosophy of prevention. An inspector sees a little bit of frost on the outside insulation. To you and me, it's just ice. To them, it's a giant red flag. It's a clue that cold ammonia is leaking through, which can make the steel underneath brittle enough to fail catastrophically. They're trained to see these tiny clues that can predict a massive disaster down the road. Okay, so we've got the heart, we've got the arteries, we've got high-pressure ammonia flowing all through the system. So now let's get to the whole point of it all, making things cold. This is where the magic happens. So inside the warehouse, you'll find these things called evaporators or chillers. This is where that super pressurized liquid ammonia is finally allowed to expand back into a gas. And that change, from a liquid to a gas, absorbs a tremendous amount of heat. It literally pulls the warmth out of the air, creating the freezing temperatures you need.
Looking at the checklist for one of these chillers, it almost feels like a pilot's pre-flight check. Inspectors are looking at the main frame, the alignment of all the plates, the condition of the gaskets. They even monitor temperatures to see if the chiller is losing any of its efficiency. Every single step is designed to make sure it's doing its one job, transferring heat as safely and effectively as possible.
But of course, the main components can't work all by themselves. There's a whole cast of supporting characters, the real unsung heroes, that our checklist makes sure we never, ever forget.
I mean, this checklist leaves no stone unturned. It covers the refrigeration pumps, making the tech listen for subtle vibrations that could signal a future failure. It checks the purger, which gets rid of any air that's robbing the system of efficiency. And it even covers the simple steel bollards, those posts that are the last line of defense, preventing a forklift from accidentally smashing into a critical pipe. It's a complete, holistic view of safety.
So, we've toured this entire engine room just by looking through the eyes of this checklist. But now, let's zoom out. What's the big idea here? Why is this simple document so incredibly powerful? And this is it. This is the whole point. The entire purpose of this meticulous, sometimes really tedious process is prevention. It's all built on one core understanding. Catastrophic failures almost never just happen out of the blue. They are always the end result of a chain of small, overlooked issues that were allowed to fester and grow.
The checklist is really a tool against our own human error. It takes this overwhelmingly complex system and just breaks it down into simple, manageable steps. It makes sure that even on a Friday afternoon, when a technician is tired and ready for the weekend, nothing gets missed. It creates a culture where looking for the tiniest imperfections is actually the most important job in the entire building, because everyone knows what's at stake.
So the next time you walk through the frozen food aisle, maybe you'll think about these unseen guardians and the humble checklists that make it all possible. And it really leaves you wondering, doesn't it? What other complex systems, from the power grid to air traffic control, rely on these quiet, methodical acts of prevention to keep our world safe and to keep it running?